Okay, so we're going to prove that if A is any event and C1, C2, and C3 form a partition of S, then the probability of A is equal to the probability of A intersection C sub 1 plus the probability of A intersection C sub 2 plus the probability of A intersection C sub 3. So let's go ahead and draw a picture illustrating what's going on here. This is a very similar situation to the one we had when only two of these sets created or formed a partition. So we have S, so we'll have this piece be C1, we'll have this piece be C2, and then this piece be C3, and we'll have A be this guy right here. So for A intersection C sub 1, I'll put that as blue, and that's this area here, right? A intersection C sub 2 would be this red area here. And then let's get a green. And then A intersection C sub 3 would be this green area. And hopefully you can see that blue plus red plus green gives me all of A. Okay, so let's go ahead and prove this. Okay, so proof. So we know that C1, C2, and C3 form a partition. So C1, C2, and C3 form a partition of S. So this implies, let me go down a little bit. This implies that their union, C1 union C2 union C3, is equal to S, and that the intersection of each of these sets is empty. So I'll show you what I mean here. And C1 intersection C2 is empty. C1 intersection C3 is empty. And C2 intersection C3 is empty. Or whenever we have this situation here where all of the sets within a family, right, are empty, then we know that the sets in this family are pairwise disjoint. So this implies that C1, C2, and C3 are pairwise disjoint. Okay, so whenever we have sets within a family where each of those sets, their intersections are the empty set, then we know those sets within the family are pairwise disjoint. So naturally, if these are pairwise disjoint, then surely A intersection C sub 1, A intersection C sub 2, and A intersection C sub 3 are pairwise disjoint. All right. So that tells me that A, so I know that A is equal to A intersection C sub 1, right? A intersection C sub 1 union A intersection C sub 2, right? A intersection C sub 2, that red, and then finally A intersection C sub 3, which is that green. Union A intersection C sub 3. Where, since we know that A intersection C sub 1, A intersection C sub 2, and A intersection C sub 3 are pairwise disjoint, that means each of these sets are mutually exclusive. So we can use our axiom 3, right? So if we have A is equal to this implies that the probability of A is equal to the probability of A intersection C sub 1 union A intersection C sub 2 union A intersection C sub 3. And now, since these are mutually exclusive, we know by axiom 3 that this is equal to the probability of A intersection C sub 1 plus the probability of A intersection C sub 2 plus the probability of A intersection C sub 3. And that is our proof.